So looking at page 344, we're going to take a look at antiderivatives of some of the special functions that we've talked about this year, like cosine and sine, any trig function, and we'll eventually get to antiderivatives of the exponential e to the x, and we just briefly touched on the antiderivative of the 1 over x, which was that natural log example that we saw on the previous page. But just for now, just as a little intro, I want to go over the sine and cosine antiderivatives. We are already familiar with the derivatives at the top. So if you were to take the derivative of sine, we get cosine, and if you were to take the derivative of cosine, we know that would be negative sine. So we're used to taking derivatives. Now we have to get in the mindset of working backwards, or thinking about what did we have previously as our function. So if we were to work backwards, aka integrate cosine, we have to think about what could we take the derivative of that would give us cosine as an answer. And notice how that would be related to the derivative of sine. So we'll say sine of x, and there could be some constant on the end, so that's why we're going to put the plus c. Similarly, we have to think about what could we take the derivative of that would give us sine as an answer. Now, we could probably narrow it down to cosine, because just like how sine and cosine are related to each other with their derivatives, so are they related to each other with their antiderivatives. But remember, we can always check our work. So if you were to take the derivative of cosine, we know that should be negative sine, okay, based off of our previous knowledge, but that does not match sine of x as the function within the integral itself. So there has to be some other piece here that we're missing in order to get this to be correct. So it seems to be like our answer is off by a negative, so maybe we'll include that in front of the cosine. So the derivative of cosine is negative sine, and notice how this other negative out front will change the double negative into a positive, which will therefore match the function. And don't forget the plus c on the end. So backwards from cosine is sine, and backwards from sine is negative cosine. We're going to use those two antiderivatives to help us with some of these examples down below. So looking at the first one, we're going to work backwards from each term individually. So much like with derivatives, how we would keep a constant by itself, we can do that same idea with these integrals. So I'm really just going to work backwards from sine of x, and up here we said that would be negative cosine. So I'll put the negative in front of the 2 and then write cosine of x afterwards. We then want to add the antiderivative of cosine. So if we work backwards from cosine, that would be sine of x, and don't forget the plus c. Again, you should always be able to check your work. If you're not sure if you found the antiderivative correctly, take the derivative of your answer, and it should match what we originally started with as the integrand. All right, looking at the next one to the right, this is a good example of how we might have another variable instead of x. We've seen position functions normally use the variable t for time, so maybe this is representing some type of position, velocity, or acceleration function because we have time or t there. You can rewrite those as x if you want to, so you'd have to change all of the t's to x's though. Or if you kept them as t's, that would be a little bit more appropriate, so I'll show you what that would kind of look like here. So working backwards from one term at a time, we're going to have to use a reverse power rule for t squared, and then we're going to have to use a special antiderivative for sine of t. Okay, just something that we have to know based off of what we said up here. So working backwards from t squared, I'm going to add 1 to the power, which would be 3, and I need to divide the coefficient by the new power. Okay, notice how the coefficient's 1. So my new coefficient would be 1/3. I then have to subtract the antiderivative of sine. And working backwards from sine, that would be negative cosine. So if I'm subtracting a negative cosine, that's going to change to a plus. And I won't forget the plus c on the end. Again, take the derivative of your answer to make sure that you did it correctly, okay, that you found the antiderivative correctly. Looking at the next one, I'm going to, oh, that should be a t there, my bad. Looking at the next one, a reverse power rule for the first, and then a special antiderivative for the second. So I'm going to add 1 to the power, which would be power 2, divide the coefficient by the new power, so 4 divided by 2 would be 2. I'm then going to subtract 3 times the antiderivative of cosine. So if I work backwards from cosine, I'm going to get sine, and don't forget the plus c. Now for our next one, I should do a reverse power rule on the square root of x, but we need to make sure it's in polynomial notation, so x to a power. I suggest rewriting it. So if I work backwards, we have to add 1 to the power, which would be 3 over 2, and then I have to divide the coefficient of 1 by the new power of 3 over 2. So that's technically just going to reciprocate it. I'll be left with 2/3 as the new coefficient. I then have to add the antiderivative of sine, which we said was negative cosine up top. All right, then plus c. Again, you can always take the derivative of your answer to check to see if you get the integrand back.